I get to talk about deployment and use, and literally, as Greg just said, I basically spent in Excel the last week trying to figure out what's the use, are there patterns, and so forth, and you get to see what I found. Truth in advertising here, I wouldn't trust any of the numbers with the number of decimals that it is given. So the basic patterns, statements, messages are true. The details of the numbers, I wouldn't necessarily put my hand in fire for. There we go. And so there's 35 institutions today. This is the latest map as of Friday, I think. And so there's 35 institutions of OSDF today, 17 origins and 34 caches across 5 continents. So we've hit pretty much the 3 dozen caches. And I'll show you the growth versus time in a second. When I then zoom into the continental USA, I found when I look at just the last month, June, the totality of June is 24.9 petabyte was read in June. If you ask yourself, how much is that actually? And you translate it into per second on average, it's 10 gigabytes per second. That's 80 gigabit per second. That means 80% of a 100 gig pipe was used to access data from OSDF via the caches. Now, if you then look and ask Fabio, what's the miss rate, the cache miss rate? The cache miss rate in the month of June was 2.7% by bytes. In other words, we went back to the origin for only 2.7% of the bytes that were delivered to the application from the caches. So we're basically saving the folks of Internet 2, ESNet, money, literally, because we're saving the network bandwidth. And we're saving the network bandwidth at this point in time to the tune of about 80% of a network pipe. And I, of course, couldn't resist to send this immediately to my friends at Internet 2 and ESNet, because I think it's a pretty impressive number for a project that has been around for not that long. So now that's the precursor. And I'll tell you in a second why I used the month of June. And I'm going to go through numbers, as Greg said. I'm going to explore the spreadsheets. And the first spreadsheet I wanted to look at is historic perspective. And I've put down here 2. This here is the hardware deployment versus time. And you sort of can see there's roughly the same. We roughly added 2 origins per year. It's roughly linear over the since 2019. And we've roughly added about 5 caches per year. So those things are roughly linear. What isn't at all linear, and it was linear for a while. So from 2019 until 2023, we roughly grew amount of reads by about 40% a year. 40% a year is actually not bad. It's a pretty impressive growth. But whatever happened in the last year is just astronomical. We grow in the last year by factor 7. If you're growing in annual reads volume by factor 7, it doesn't make a whole lot of sense to do annual averages anymore, because they've changed by a factor 7 throughout the year. And so that's why I took the June numbers. And I'm sort of switching back and forth between June numbers and annual in this talk because of convenience, what I had available. But really, we should be looking at the June numbers as a representation of where we're at today, because we've grown by factor 7 between last June and this June. And that kind of growth means that last August's number is probably not relevant for this June. I call this, I want to call this the Pelican effect, because it so happens that this massive growth happened with the advent of Pelican. And I'm not sure actually where the growth really comes from, whether it is actually due to effort available and engage the community. I suspect it has many origins, and you'll see as I walk through what's current that it actually comes from many places. So fun facts for the month of June. I already mentioned 24.9 petabyte read. The next fun fact is 10% is counted for the OS pool. So 10% of the total reads from the OSDF was from users of the OS pool. The other 90% come from elsewhere. And I'll show you what elsewhere is in this talk in a little bit. But let's go to the OS pool first. And so if you look at June 2024 OS pool numbers, roughly a third of OS pool users use the OSDF. That is a massive change from last year. Last year, it was sort of a little bit of OS pool use happened to use the OSDF, but the vast majority didn't. Now it's a third. And that third comes either which way you look. A third of the users use the OSDF, a third of the projects use the OSDF. And so in the sense of the social participants of OS pool that use the OS pool, a third of those use also the OSDF. Then if you dig down, what are they actually doing? It turns out that OS pool users transfer small files with Condor and large files with OSDF. Why am I saying this? I'm saying this because only 2.3% of all file movement is done with the OSDF. 97.7, I guess, of the file movement is actually still done with Condor for OS pool. So that's a striking statement, right? And then if you look at the bytes transferred, almost 50% of all the bytes transferred in the OS pool are actually transferred now via OSDF. That's an impressive statement for only a third of the given that only a third of the users are using OSDF.
But you may want to say that it's annually, it is 2.3% out of 5 billion transfers.
Yes.
So it's a huge amount.
And so then I wanted to sort of visualize for myself what does the data use versus CPU hour use, how does it actually, where do these people sit? And all of those blue dots is a project. Each of these blue dots is a project. And a project in OS pool that uses the OSDF. And I would say to first order, it's sort of uncorrelated. In other words, the amount of CPU you're consuming and the amount of data that you're reading is basically to first order not correlated. Because if you look at this here and squint, in this quadrant over 2 orders of magnitude, there's basically no real correlation. And so there is a vast spread of the amount of data per clock cycle, so to speak, that is being used. And applications go all over the map. And also, I want to point out to the values here. We're talking between 10 terabytes and a petabyte read by the majority of the users who actually use the OSDF for on the OS pool. Even the OS pool users move petabytes. And as an individual user that read petabytes in a single month, that's actually a petabyte in a single month. There's one out here. There's one project that has actually read a petabyte in the June. And it's an OS pool user, and I'll tell you who it is in a second. So this now is the top OS pool data users or object users, as Miron likes to say, in June 2024. And if you sort of squint at this, these are the PI's names because this is what we're making public. We're not making public usernames, only PI names for all kinds of good reasons. These where they come from in our institutions, and this is the science they do, and a little description, the number of terabytes read and the CPU hours used in June. So the winner, so to speak, with moving a petabyte is a Wayne State University project. And my message is it ranges over a wide range of sciences and institutions and locations, enormous diversity. Now I go to the last year because that's where I have data for working set size, the volume of unique data, and the volume of data read last year. And I can actually make distinctions on what's the access pattern. And and then the reuse multiplier is just the ratio of the two. I want to show you some things where I'm first looking at all the namespace and ask myself, what's the working set size? How much unique data do they have? And I'm looking at anybody with more than 10 gig of data. There's 100 namespaces, and then I'm going to data, and I do the x-axis, the working set size, and the y-axis, how many times has this data been read? And you're seeing here, the scale is 1,000,000 times read. So there is people who have read their data more than 100,000 times this. And then there's people who have 100 terabyte, 10 terabyte to 100 terabyte of data, and they still have read their data about 100 times. And a little bit more and dug in and looked at this as this is the amount of the working set size versus total read. So working set size is here and total read is here. So if you then look just at the people who have read more than a petabyte in a year, basically the big consumers, where do they fall into? And you can sort of almost, you squint a little bit, you see a cluster down here, a set of only 10 gig or between 10 and 50 gig worth of data, unique. So they're the ones who have read the same data more than 100,000 times. And so I'm going to show you who those are. And then there are these guys who have more than a terabyte of unique data and basically, therefore, are basically large, read it multiple times, order 100 or so. And who are these people? And it turns out that they are very, very distinct groups. In fact, the people who have a petabyte read but have more than a terabyte unique are all from international collaborations. It's the kind of LIGO, IceCube, Koto, dominated either by gravitational wave observatory communities or by neutrino physics experiments. If you look at all of these dots in that, top area, there's one dot that isn't neutrino physics or gravitational wave. So it's a very specific type of people. And then if you look in the other range, petabyte read, out of 10 to 50 gigabyte data set, there are 7 namespaces like this, and all 7 belong to OS split. And then if you look actually in the in-between, if you went and looked at these guys, it's sort of a little bit of a mix. There's some of this and some of that. And if you're sort of looking more generally, it literally is this is unique for just collaboration. It's sort of a mix of both. Finally, last statement I have, last message. For the first time, I've seen in the spreadsheet of use things that are not on OSG at all. In other words, OSDF is starting to be used. Seen is that there are 10 namespaces in OSDF that belong to NRP communities, where I am reasonably certain that those NRP users have no use of OSG at all. They only use internal mechanisms from NRP. And so OSDF has now communities that go beyond high throughput computing to some degree. And one of the in particular is, I know that people only use Jupyter Lab, basically so via NRP. And this petabyte was read from about 311 terabyte of unique data sets. So that's new and different. And summary conclusions, OpenScience Data Federation has seen a 7x increase use within the last year. Roughly a third of all OS pool users use now OSDF. And we start to see usage of OSDF from outside OSG. Thank you very much.